All right, I think I'm just going to get things moving. Try to give the presenters as much time as possible today. Um, People will show up a little bit later, and that's all good. So, welcome to the second winners webinar for the Integrated Home Competition. We have three winners lined up to present today. Unfortunately, one who was scheduled couldn't actually make it, but still have three. We're going to have four initially. So, agenda for today. I'm going to provide super brief background on the Integrated Home Competition. And then we have the three winner presentations, the A.O. Smith Voltex Smart Electric Hybrid Heat Pump Water Heater, the Lumen Smart Panel, and the Harvest Thermal Harvest Pod. Each presentation will be 5 to 10 minutes long, and then there'll be some time for questions afterward. Feel free to either unmute yourself and ask them directly or put them in the chat, and we'll make sure they get answered. So I don't know why these ended up gray. I apologize for that. But really quickly, just a bit of background on the integrated home and CEE and the integrated home competition. So in our work, we were hearing a lot that, the market around energy has been, changing a lot, and that the time and locational value has really gained, a need to be captured. And for that, we ended up basically coming up with the Integrated Home Initiative, which describes basically what is the residential smart home of the future. And specifically, the CE Integrated Home is a connected, fuel-neutral, grid-interactive, efficient home where all the systems, lighting, appliances, HVAC, etc., all seamlessly communicate and optimize value amenities to both consumers and members. Now, this obviously has different benefits for both consumers and for utilities. For the consumer, it helps to address their preferences automatically. It'll improve their consumer experience through more customization and personalization options. And overall, it'll help add value to the consumer energy experience. For utilities or CE members, this integrated home reacts to the dynamic value of energy. It can respond to utility or third-party demand response signals, and overall will help contribute to safe, low-cost, and reliable energy. In order to kind of help, fill out this vision and seek out these products that meet this vision, we started running the Integrated Home Competition a couple years ago. And this is really just a way for us to help, seek out and identify new and innovative residential products that are coming to market, and really help to reward manufacturer leadership in this area through the promotion of solutions that demonstrate interoperability, reliability, and simplicity. And we've been running it for 3 years now. We've got a great suite of winning products, and I'm really excited about the ones we have this year. Really quickly, just want to thank all of our competition sponsors. We have a lot of CE members and other organizations that are very, interested and bought into this integrated home vision. So thank you to our sponsors. And with that, I'm going to leave the rest of the time for the winners.
Thank you, Eric. Good morning or good afternoon, everyone. It's a pleasure to be here. Appreciate your attendance and time, and thank the CE team for putting this together. So I'm Pierre Delforge. I head up product and operations at Harvest Thermal. We were founded in 2019 in the California, San Francisco Bay Area, and with a mission to make heat pumps more affordable to install, to operate, and to be more grid friendly. And we had two key design ideas to make this possible. The first one is, instead of having 3 separate devices, one for heating and cooling, one for hot water, and one for energy storage, we designed one system that can do all 3, and that basically can be cheaper to install than all 3 separate systems. And the second key idea is leveraging software and thermal energy storage to optimize for energy efficiency and for energy costs. So, with that in mind, I'm going to go through the next slides and present the system. So the system is really a hydronic system. It's using standard off-the-shelf components for a heat pump water heater, a standard hot water tank, and it's delivering hot water both for domestic hot water users as well as for hydronic heating through a hydronic coil and an air handler, or through a radiant system. So you have both possibilities. Most of our customers use forced air hydronic, but we do have some radiant customers as well. And we know that today most customers can't do that cooling, so we also integrate a separate condenser into the same air handler with a second coil, and basically blow hot or cold air through the same duct system. And the combination of both components are orchestrated by the harvest pod. So the key, what's new here is really the harvest pod. It's the smart controller, which is both the brains and the heart of the system. So the heart of the system, because it's basically a packaged hydronic system. Your typical hydronic system would be assembled on site with valves and pipes and pumps and all these components you'd have in a basement somewhere. And we basically package this, assemble it at the factory, test it at the factory, and the installer basically has to put it up on the wall, connect to the pipes, plug and play, basically. So it reduces the cost and it makes this type of system affordable in residential settings. And the brains of the system is because it's a smart cloud-connected controller that uses machine learning and advanced algorithms to optimize when the heat pump operates and to turn this standard hot water tank into a smart thermal battery. So we know at every point in time what is the state of charge of the water tank in terms of how much hot water, usable hot water, is in the tank. And we manage this battery, we manage this tank as a battery by running the heat pump at the cheapest and cleanest times of day to ensure that we always have enough hot water for heating and domestic hot water needs for the occupants while optimizing for their energy costs. We also use the second condenser, the AC condenser. By making it a heat pump, we can use it as supplemental heat for the hydronic system. So that expands the capacity of the system to homes that would not be served by the hydronic system alone. And it's still primarily a hydronic system. Like, the hydronic system will do about 90% of the heating load, but we are able to use the heat pump as backup heat. So now you have backup heat at heat pump efficiency level, and in most cases, you don't need any strip heat or any electrical resistance backup. So this, in terms of results, we basically are able to decouple the time of use of heating hot water with the time of use of electricity. We deliver about 30% energy cost reductions compared to conventional heat pumps when using time of use rates, or up to 15% even without time of use rates, just from energy efficiency alone. We are able to make both heating and hot water flexible. So heating and hot water represent about 2/3 of a home energy use, and the system makes basically these 2/3 of home energy use flexible, able to respond to demand response signals with CTA 2045, time of use. So basically optimized for people's energy costs using their time of use schedule. And we can also respond to dynamic price and emission schedules as those become available from utilities. And the last one, we provide a connected experience, both to the customer with an app that we are about to launch, but also to the installer and the contractor to provide remote diagnostics and support, and allow them to only have to go on site once instead of having to go and diagnose and then go back to the warehouse, get the parts, go back and have 3 or 4 truck rolls. Typically, we're able to detect and solve problems either entirely remotely or with just 1 truck roll. And last one for the grid, with the grid connectivity to make it grid responsive and optimize, make this 2/3 of home energy use grid responsive. So moving on. So how the 4 tenets of the integrated home competition. So first one, in terms of energy efficiency, the results speak for themselves by optimizing when the heat pump runs, and also at what time of day. So typical heat pumps tend to run when it's coldest outside. That's when people need the most heat. And by using thermal energy storage, we actually run the heat pump when it's warmest outside, and we use thermal energy storage when it's coldest. And that difference in timing can be worth about 1 point of coefficient of performance gain from an efficiency perspective. So you take one of the most efficient heat pumps on the market already, and you run it at the warmest times of day, and that's how we are able to get a really high, annual field measure. That's not lab measure. That's in the field with all the things happen in the field. Efficient coefficient of performance. And even when you account for all the energy use of the system, pumps, controller, thermal losses and everything, we are just around 300% field annual system performance. On the load management and demand flexibility side, as I mentioned, we can shift about 90% of hot water and heating load. The main load that we do not shift is the fan, because we do run the fan, the fan coil whenever people want heat, so that doesn't get shifted, but the heat pump energy use gets shifted off peak. And this little diagram or the chart on the bottom left, that's a demonstration that we did with Lawrence Berkeley National Lab and the CEC, California Energy Commission, where they send us a dynamic price signal, which are the blue bars, so the price varies every hour. In orange, you have the thermal demand for both heating hot water in the home, which, as you can see, is fairly coincident with high prices. And in green, it's that reshaped load when the harvest system uses energy, which is basically shifted in the low price period of the day. Customer satisfaction. So this is really a premium experience, premium heating experience system. It's, we have modulated variable speed heat delivery, leading to really constant, stable temperatures. You typically don't hear the system when it's on and off. It's more like in an office style experience where it's in the background, it's maintaining the temperature at a constant temperature. And it's, reliable, and our customer base is really raved about the system. We have really high customer satisfaction using the Net Promoter Score metric. And last, in terms of security and privacy, so we've designed the system with privacy and security in mind from the start, and using best practices in terms of cloud communication, personal identifiable information. And we've also designed it so that connectivity is nice to have but not required. The system will function without connectivity. Users can opt out if they wish. The only thing that will not be available without connectivity is the added, remote diagnostics, monitoring, and using the weather forecast to optimize heat pump performance. So last, in terms of market adoption, so the system is designed for both existing and new home. The majority of our customer base today is existing homes, because primarily new homes take more time, but we are working with new home developers right now, and we have a number of projects in the pipeline. As the charts on the right shows, we've deployed over 100 systems to date with strong demand, and we're continuing to grow that demand and our installer network as we speak. We launched the system in the California Bay Area. We're now expanding up and down the West Coast, and we're working with other partners, including in the Northwest and in Efficiency Vermont, on implementing cold climate pilots this winter. And we're interested in discussing any other pilots with you. So feel free to reach out to me. Be happy to discuss that. The last thing I wanted to mention is we've designed a system with a lot of data. It's a data-rich environment. That's both because of controls. We need a lot of all this data for doing smart controls, but it can also be used for M&V. So the system we have on every system we deploy minute-level data as long as the system is connected, and we can use that for M&V. So it makes project monitoring much more cost-effective because it's built into the system already. So I think that concludes my presentation, and happy to answer any questions.